Welcome to solverfy.
All right, when we look at these different structures, we see that they are all very similar, but our numbers are going to be different, mainly the placement of the methyl groups that we're looking at in terms of our 7 carbons in our compound. So our first one, right, we do have 7 carbons. Now, when we look at these, okay, remember we can draw these using that line structure, okay? So every point on this line is going to represent a carbon, and we're going to assume that the appropriate number of hydrogens are attached, okay? So we have 2, 3, 4, 5, 6, 7, right? So that would be a heptane molecule. It's the same as writing out 7 carbons single bonded to each other with all the hydrogens to each one. Okay, but this is just a lot faster to draw. Right? So if it's 2, 2, okay, so carbon number 1 is here, right? Carbon number 7 is over here. Okay, or we could reverse it and that would be fine too. It would just be a mirror image. So if we look at carbon number 2, okay, that means we have 2 methyl groups. They're both coming off of that second carbon. So it's a CH3 and a CH3 group there. Okay. So that would be our 2,2 dimethylheptane. All right, from there, we're going to see similar variations. Okay, so for the next one, 2, 3, 4, 5, 6, 7 is our base. And here we're looking at a 2, 3. Okay, so if we go with the same convention, 1 being on the left, 7 being on the right, right? Carbon number 2 would get a methyl, and so would carbon number 3, right? So that would be 2, 3 dimethylheptane. Okay. All right, next up we have 3, 3, right? So you get the idea, I think. So 2, 3, 4, 5, 6, 7. Okay, so our third carbon would have 2 methyl groups attached to it, 2 CH3 groups there. Okay, so they would both be off that third carbon, right? And then last but not least, we have 2, 3, 4, 5, 6, 7. Okay, here we have 2, 4. So if we still, methyl is just still that 1 carbon group, CH3. So that's our second carbon and our fourth carbon.